Hello students, the next part of the chapter is static electricity, which is the part B of the chapter. Now static electricity means the electricity which take place due to motion of electrons, due to motion of charges. Now it can be protons or electrons. Electrons are negatively charged and protons are positively charged. So it can be motion of charges, or you can say electrons, and they can be negatively charged or positively charged body. There are two types of body: negatively charged or positively charged body. Now we'll just make use of some substances like glass, plastic, ebonite, amber, nylon, hard rubber, etc. And these are all rubbed with wool, fur, silk. Then they acquire charge. They acquire an electric type of charge, which is caused due to friction. Friction means because of rubbing. Now all of you must have done this practical in your daily life, that when you just comb your hair, which is a little oily, when you just comb your little oily hair again and again and just take a tiny bits of paper, you will see that when you will just bring the comb rubbed with your hair, you'll just see you just see that comb will get charged, and because of this charged body, the comb will be a charged body, and because of these charges, it will just attract these tiny bits of paper towards itself. It will just work like a magnet. So in this way we can say that comb got charged because of rubbing of comb on the dry hair, and it would work better if your hairs are little bit oily. Next thing is, you can do the same experiment with pen as well, or with scale also. So this is the thing, this is a small activity done, and you can do these activity at home also to check the static form of electricity. Now students, we have some experiment. Scientists have done some experiment to just show the body which type of charges are there in the body, and what type of charges repel and what type of charges attract each other. Okay, now this is a glass rod and this is the ebonite rod. Now glass rod rubbed with silk and ebonite, and this glass rod, in this experiment we have seen that we took one glass rod A and another glass rod B. Both are rubbed with silk and they are brought together. What we have seen that when A and B are brought closer to each other, what happened? They start repelling each other because they both are filled with similar charges. In the same way, ebonite rod A and ebonite rod B rubbed with fur or cat skin, what happened? What we have seen, that again they are repelling each other, but because again here the charges are same, and that is why they are repelling each other. In the same way, in the another experiment, what we have done is, we took a glass rod rubbed with silk and another rod, ebonite rod, rubbed with fur or cat skin. What we have seen, that both the rods, they are attracting each other because they have opposite charges. So similar charges, as we know that in case of magnet, same poles they repel and different poles they attract each other. In similar way, same charges repel and opposite charges attract each other. Now the next part will just study that what type of charges do glass rod have when it is rubbed with silk, and what type of charge do ebonite rod have when they are rubbed with fur or cat skin. So let's see. Now with the glass rod, they are rubbed with the silk cloth or with a silk with silk piece of cloth. What happened? The glass rod, after rubbing, it is having a it acquires a positive charge, and the silk itself become negatively charged. In a similar way, when ebonite rod is rubbed with fur or cat skin is having positive charges, and the ebonite rod is having negative charges. So glass rod is acquiring positive charges rubbed with silk, and ebonite rod is acquiring negative charges when rubbed with fur. So that is why when these rods are brought together, they attract each other because they are having opposite charges. Now the next thing is we have, that is, conductors and insulators. Now conductors, we have already studied what are conductors. Conductors means which carries current, which are good conductors of electricity, which through which the electricity can flow. For example, silver, copper, iron, brass, mercury, carbon, human body, etc. They are conductors of electricity, that is, they allow electricity to flow through them. But we have some insulators as well, that is cotton, rubber, plastic, wood, paper, glass, ebonite, mica, wax, wool, pure water, etc. They are insulators of electricity, that is, they do not allow electricity to flow through them. Similar way, in terms of charges, if we just, because we are talking about static electricity, and static electricity means on the other hand we are talking about charges. If we are talking about static electricity, it means we are talking about electrons, we are talking about charges. So those so substance which have large number of free electrons are called conductors, and those with very small or no free electrons, that is, they are called insulators. So conductors allow the charges to flow through the motion of free electrons, but insulators do not allow charges to flow through free electrons and are not available for motion. So this is the difference between insulators and conductors. So conductors, we can conclude that conductors, free electrons are there in them, large number of free electrons are there, and insulators, very small or no free electrons are present. Now the another important thing is how we charge the body in conduction method and how we charge the body in induction method. Now students, you can just have a look to the diagram part. Now you can see this is a positively charged glass rod, and in this is the process of conduction. Now in conduction we touch the body together. Now this is a metal rod and this is the insulating stand, and this is our hand, which is insulator. Now we just brought up positively charged glass rod. Now in conduction, what happens when we just touch this to the metallic rod? What will happen? The charges of these positive charges will flow through the metal rod, and this metal rod will also become a positively charged body. So we can say that the glass rod B is positively charged, so it has the deficiency of electrons. When it is touched with the metal rod A, the free electrons of rod A move to glass rod B due to loss of electrons in glass rod A. Now in glass rod A, the electrons are lost and it has become positively charged body. Now you can note that an insulator cannot be charged by induction because it does not contain free electrons. As we have just studied, the insulators have very small or no free electrons. So it does not allow free electrons from the charged body to flow towards itself. So you will note that the metal rod A, to charge the metal rod A negatively, you have to bring ebonite rod rubbed on fur is touched with rod A. Now if you have to just, this is a glass rod, this is a positively charged glass rod rubbed with silk which is brought, and it acquires positively charged, so it has given the charges to it. If you just want to make this negatively charged body, you have to bring an ebonite rod which is negatively charged when it is rubbed with fur. So this metal rod will also become negative charge. Now coming to induction part. Now induction part is quite different from conduction part. Now in induction part, we do not touch the body together. We just bring the body in very close contact. We just bring two bodies to very close contact, but we do not touch the body. But in conduction we were touching the body, but in induction we don't touch the body. Once you bring a positively charged glass rod, what you will see close to it, close to the metal rod, what you will see, the 2 points are there, P and Q. What you will see, students, you will just see, once the positively charged glass rod is brought near to it, you will see negative charges will be developed at the corners of point P of metal rod, and positive charges will be acquired at corner Q. So opposite charges acquire in induction. Whenever a positive charge body is brought over here, positive charge body is brought, the front part will have negative charges and back part will have positive charge. I hope you are clear with it. Now what will happen, you can see further this, and this body is also earthed. Earth means it is getting electrons after earthing. So what will happen, once you remove this glass rod, this whole metal rod will become negatively charged. Now student, my question to you is, what charges will acquire if acquire on point Q on the corner of metal rod at the point P? What charges will acquire if you just bring a negatively charged body? That is, if you bring an ebonite rod, you will see positive charges will acquire at point P and negative charges will acquire at point Q. That is, opposite charges will acquire here. You will get, if you just bring an ebonite rod to it, ebonite rod, if you just bring close to this metal rod, and this ebonite rod is negatively charged, this ebonite is negatively charged, so when you will bring close to it in the process of induction, you will see positive charges will acquire at the corner of point P, and at the corner this side, on the back side, negative charges will be seen. So this, and once you remove this, you will see positive charges throughout. In similar way, when this rod is being removed, the full metal rod is negatively charged because it has been earthed, and because it is earthed, so electrons are moving from here to this metal rod, and this metal rod totally will become negatively charged body. So just they have given a note over here, to charge the rod A positively, you have to bring ebonite rod rubbed with fur close to it. So this was the two processes in which charges flow through the body, that is through the process of conduction and induction. The next is type of electroscope. Now what is an electroscope? Electroscope, it is clearly given in your book that electroscope is a device which is used to detect the presence of nature of charge on the body. Means what type of charge the body is having, whether the body is positively charged or whether the body is negatively charged. Now there are two types of electroscope. The first one is pith ball electroscope and the second one is gold leaf electroscope. Now what happened in pith ball electroscope? There is a pith ball and the silk thread and insulating strand. Now to test this, what happens? Bring the body near to the pith ball without touching it. The pith ball moves towards the body is charged, but if the pith ball remains same stationary, the body is uncharged. Now to test whether the body has positive or negative charges, what we do? Take a charged pith ball electroscope, that is pith ball is provided with some charges. Suppose the ball is positively charged, and bring the charged body near to the pith ball without touching it. The pith ball moves away, it means the body is positively charged. If the pith ball is positively charged, and if you have brought the body and the ball moves away, it means the body is positively charged. And if it does not move away, it means if it attracts, it means the body is negatively charged. So this is the way we just test the charge on the body, bringing near to it. The next very good type of electroscope and very much you can say mostly used, that is gold leaf electroscope. Now gold leaf electroscope, we have insulator plug, brass stick, and these are gold leaves made up of gold. This is a metal foil and a glass case. Now what we do is, again, charged body is brought near to this and we just touch this brass disc. This leaves will stretch, will move apart, and if the body is not charged, it will be in parallel form. Again, if the body is what happens? You just take a charged gold leaf. We have taken a charged gold leaf, and suppose this electroscope is positively charged. What will happen if you just bring a glass rod to it, or you just brought a positively charged body to it, and previously the gold leaf was already positively charged. What will happen? These leaves will move so apart, and these leaves move so apart because they just repel each other. But a negative charged body is brought in contact with the brass disc. What will happen? These leaves will move a very little apart because they try to attract each other, because the negative electrons will flow through this gold leaf. And once the gold leaf is negatively charged, again a negative charged body is brought, again the gold leaf will move so apart, and again a positive charge body will bring in contact with it, with a positively charged body. What will happen? Again you will see a very small diversion in the leaves. So this is the working of gold leaf electroscope. This table, you have to go through this table. This a summary of what we have just understood now. The next thing is atmospheric electricity. Now there are electricity is seen in the atmosphere as well, and we can see the electrons in during the thunderstorm, that is during the lightning. So what happened when the charged cloud, the clouds are also having charges In them, the charged clouds pass over the earth. What it happens, it acquires opposite charge by induction. A spark may occur between two positively charged clouds, and that is why we can see the lightning in the sky because of the charged cloud. What happened, the charged cloud, because of induction, they have opposite charges, and that is why we can see lightning in the sky. Now the effect of lightning on the object is very dangerous and serious, and that is why we are having lightning conductor. This is a device which protects the big buildings, and that is why big buildings are having lightning conductor on top of it. So student, this part is very easy, and you have to go through it by yourself. And you have to study this part by yourself. Now we have covered all the part of this chapter, which is the last chapter of the book as well as the last chapter of your course of final examination. With this we are ending, and I'll send you the question answer part in the next assignment.